Okay, so third and last video on controlling the 15-segment display using the 7219 LED controller. If you've seen my previous videos, you probably know about the clock that I have here. This is the DeLorean time circuits inspired thing, or at least it's a prototype of it. I won't go into the details of why I think this is the coolest clock I've ever owned, but hint, GPS driven, go watch the other video. I did want to build this thing in such a way, or design it in such a way that I could hand off instructions to anybody who wanted to build one and they could do it. Unfortunately, there are a few problems with it. Well, one, it's way too dim to read in daylight. I'm going to turn the lights on so you can actually see the rest of what I need to cover in this video. Yeah, like you can't see it anymore. But one of the biggest problems with it is simply the fact that while the soldering is easy, the 400 plus wire wrap points in it are not so easy. So giving somebody instructions on how to do this just isn't possible, so this is not something I can hand off to the general public. Alright, so that brings us to our second shot at this, which was documented in the other video. This is a pair of 7219 controllers that are driving 15-segment displays. There's too much wiring in there to really see it very clearly, but it is much brighter. It is readable in daylight. But what's more, it uses components that are common enough that that most electronics hobbyists, especially if they do have 15-segment displays lying around, will probably have around. They'll have 7219s, they'll have transistors, resistors, capacitors, etc. And so this circuit I actually just built with stuff that I had lying around in the house. I didn't have to order anything special. And that was my hope, to build the time circuits again, providing simple instructions that anybody could follow, using stuff that an electronics hobbyist might have lying around, and if they didn't, were cheap to acquire. So I made a half dozen passes getting all this to fit on circuit boards, and met with limited success. What I eventually had to do was build a multi-layer circuit board. So I have, well, I'll just use this here. So I have, a great shot of the Duracell box. So this is what the displays end up looking like when they are. Let's see if I get focus. Looks about right. So this is what the display looks like when it's on the circuit board, and the idea was that the first four would be, this would be month, day, year, hour, minute, second. That it's, I think it looks really good, but unfortunately, as you can see, the number of pins for these displays causes this wall of holes to be drilled in the PCB. And it makes it incredibly difficult to route past them. So if I had, down here on the circuit board, if I had a 7219, getting the 9 connections to the top row past the bottom row is basically impossible. So my idea was to put the 7219 on another circuit board and stack it on top of the display board. I worked with that for a bit and found that this board still wound up just being too dense to work with. So I did this. There's 2 circuit boards stacked one on top of the other, one controlling the top half of each display, the other board controlling the bottom half of each display, and then the 2 of them being sandwiched on top of the third board. It works. Got it going right over here. I'm going to do this without banging the tripod around too much. But again, some engineering decisions came into play here. I experimented with the idea of using headers, and just turn the lights off, maybe you can't identify that thing, but of using headers to connect the boards together instead of just running a solder line between them. The reason for this was if you screwed something up on, you know, one of these little subboards, then you could just pop that subboard out and solder up a new one and plug it into the whole project, and you're done. You wouldn't have to replace, say, an entire one of these things that you've already soldered 16 digits to and 4 subboards and God knows how many other components. Unfortunately, I think you can see right here, the bottom half of the 3rd digit is out, and that is due to a bad connection in between 2 of the boards. And there's just nothing to do about it. You would have to replace the middle board because it's the connection between the top board and the middle board. Sorry, you'd replace the middle board, but it's the connection between the middle board and the display board that's out. So you could get better reliability if you were fantastically accurate engineer with a soldering iron, which I am not, and just soldering the whole thing together so they don't come apart. I don't want to do that to anybody who wants to try this project. As it is, and let's just do this. As it is, this is a fairly nasty bit of kit, as you can see. Let's get a little light on it again. So while it works, and while it is fairly modular, it is not simple to build. It is not something that I would hand off to, say, my 14-year-old son and try to give him instructions on how to build it. So the idea was great. If you are trying to one-off a project that drives 15-segment displays and you have 7219s lying around, it works. And it's wonderful. Unfortunately, it is not something that I'm not shooting this again just because the cat is making noise. It is not something that it is not something I'm going to hand out to the general public. So despite the fact that the cost of one of these modules ends up being like, I don't know, $5 or $6, I'm going to redesign this to operate on the, what is it, 6599, is that correct? No, 6955. 6955s are about $18 a piece. So each one of these modules is going to be replaced by an $18 piece of hardware that is going to be very difficult for your everyday schmo to solder into place because it's a 36-pin SSOP, which means that the pins are half as far apart as they are here, so 1/20th of an inch instead of a 1/10 of an inch. It means that if you want to fiddle with one for the first time, it's very difficult to breadboard it. It means that the accuracy involved in soldering the things that is required is going to be very high. It is not something I'm terribly comfortable doing because I suck with a soldering iron. But I guess I'm going to learn because I really want to finish this project. Unfortunately, all the circuit boards that I've printed for this are just going to go in the trash, and we will start fresh. If anyone's actually interested in how I did this, I can probably provide a decent circuit diagram. The first video should provide you with enough information for you to do it yourself, but anyway, just thought I'd provide a wrap-up and let people know that as far as I am concerned, this avenue on the project is canceled because I think that it would be too much work to hand off to people. So anyway, hope this helps. Kind of doubt it will, but I hope you found it interesting. See you when I got something new.